Just to review about the previous class, we have completed the synthesis method. That means how to get the nanoparticles. And nanosynthesis is different and preparation of the particles is different. Please don't get confused. There are two methods of preparation of the particles. One is already it is available naturally, that we are going to reorient them. That is one method. Other method, the nanoparticles ourselves by using the other methods. Okay, so while you are talking about the other method, the preparation, the physical method and chemical methods. The physical method is physically we are going to use the ball mills. Okay, high pressure ball mills herein. There will be a roller structure and there will be hardened steel balls. And while you are going to rotate at very high speed, what happens? Due to the collision between the steel balls, in between the steel balls, this powder will be smashed. And what happens? We'll get nanoparticles. And these nanoparticles will be received again and it will be taken. And every cases you take whatever the method you want. So in all the method, it is not possible to yield all 100% metal to be converted into a nanomaterial. It is not possible. Okay, there are certain the initiatives we have to take in order to get the proper optimized method by which we can get the nanoparticles. Okay, the physical method, please remember ball mill, laser ablation method, gas condensation procedure or processing, and chemical method by using the chemical sol-gel synthesis, phase that is stabilizing lozenges, and the precipitations method, that is the chemical vapor condensation, catalyst chemical vapor and deposition, and the chemical vapor deposition method, and that is electromechanical method, electrochemical method. These are the different methods. Whatever the preparation you take, whatever the method you take, to have a suitability of any material to be nanoparticles, the identical size of particles should be there. That is mono-sized particles. Uniformly distribution should happen. And they should have the identical shape and morphology. The morphology and the identical shape should both are same. And identical chemical composition and crystal structures and monomer dispersion, and this one no agglomeration. Oh, these are some important for the identical requirement we need to expect from any material that can be used for the or that can be taken for the synthesis of nano material. I hope you understood. The nanoparticle is different, nanosynthesis is different. In nanosynthesis, we are going to make the monomer the continuous chain so that it will be forming a structure. A structure will be formed, and based on the requirement, these structures will be synthesized for a specific application. Okay, maybe it is a medical application or it may be chemical application and XYZ, whatever the applications. Already we have come across the varieties of applications we have based on the the mechanical grinding method. Already you know that there will be a mechanical grinding method. Already I told you here at our institution also there is a mechanical grinding method. When the small the ball mill is there, nanoparticles preparation ball mill. And here in this case, what happens? It can be rotated at specific speed, and the milling chamber will be a cylindrical one, and both sides to be closed. And the material which has to be converted into nanoparticles or nanopowder will be filled into. We cannot pull the very big blocks of the metals. Again, it should be taken to a required shape. It will be made into a powder and that will be put into this. Okay, and this will be rotated at very specific speed, optimized speed, and the different balls will be put into this. And while they are rotating, what happens? You can see here in this case, and there will be a pressure applied on these steel balls by means of this. And what happens? These nanoparticles will be smashed in between. And please remember here a specific speed and the type of the steel balls and the characteristic of the steel balls, that is mechanical characters, and the rate at which these will be bombarding each other, all these will be mattering. Okay, so once you have taken a particular setup, we have to make the optimized route by which you can maximum particles. Okay, even if you go for the high production rate also, around 25 to 30 grams per hour we can generate, not more than that. Okay, and another one important thing is that while you are working, you know that these the steel balls will be colliding each other. Due to this, what happens? There will be a lot of friction, and due to this, heat will be generated. If the heat is going beyond or above 100 and up to 200 degrees centigrade, what happens? The metal which you have taken to convert them into a nanopowder will squeeze themselves, and plastically they'll be deforming. Due to this, what happens? The nanoparticles will not get, it will not yield. Instead, it will become flattened. So we should have to avoid, or we should have a specific speed and the type of balls and the number of balls. All this will be mattering for the different nanoparticles. Okay, this is one. Please try to remember that. And this may be useful for so many other purposes. Okay, so many purposes to nanoparticles preparation and getting the uniform size particles for specific applications, or sometimes we are going to take this metal for the normal coating purpose. It will be mixed with some kind of sol gel and we can make a painting. As I told you in the 8th century till some of the articles, the handmade painted things, they have been laminated with the transparent coating that is called the nanometal coating. It was existing earlier, the Indian history. Okay, now today also we can find its applications. It can be mixed with the rubber and it can be made laminated over some of the surfaces wherein you require to reduce some kind of rust formation and to increase the aesthetic view, and for all this purpose we can use these transparent materials. Now, the limitations, what are the limitations of the ball mill? As I told you just now, the limitations, once we are working at very high temperature, it is above 100 and up to 200 degrees centigrade, what happens? The associated particles, the associated metal, that is metal which you need to convert them into a nanoparticle, will plastically deform. Instead, they grinded, it will become flattened. That has to be avoided. And what happens due to this? What happens? It is difficult to break them into particles, subparticles. Okay. Another one important thing is there will be the steel balls, and inside surface of this cylindrical portion also will be a steel one. And what happens due to this high speed action, centrifugal action, the steel balls will be hitting to the surface of this tube, and they'll be hitting themselves. Due to this, some kind of the ferrous powder also will be formed. It will be very, very difficult to remove this ferrous powder which is mixed with the nanoparticles. There is no as such mechanism by which we can remove them. This is one. What happens due to this? The unwantedly, which is not required, that ferrous nanoparticles also will be present. And what happens? The mechanical and some other chemical behavior of the system will be changed when you test them after synthesis. So this is one of the problem, or this one. Then one may ask me, then what are the other the alternate methods? If they definitely we cannot avoid mixing of iron particles with the nanoparticles, and definitely the physical, mechanical, and chemical properties will be changing. Okay, while testing it will become very difficult. So so many other alternate methods also available with us. So the chemical method. The chemical preparation method, please remember, that is the mechanical preparation method, that is physical modeling. And another the sol gel process. The sol gel process in this, the precursor solution, that means the solution which yields to the nanoparticle will be called as precursor solution. This precursor solution will be kept in a container and we do chemical processing, that is hydrolysis we do, and it will be stirred at very high speed. So due to this, what happens? The gel formation will take place. A sol gel formation will take place. after condensation. Okay, after condensation. And the metal alkoxide solution which is formed, which will be taken, which will be dried off. We are going to take it for the drying process. The gel formed or gel formation, please remember a container which will be having the stirrer. In this, a precursor solution will be put. The precursor solution is one, the solution which yields to these nanoparticles. That is called as the precursor solution. And it will be stirred at very high speed. And this is a chemical processing. In other way, we say it is a chemical processing. And we do hydrolysis and condensation. So due to this, a gel will be formed. That is called the sol gel process or sol gel formation. The solution to gel formation. The sol gel formation is process is solution to a gel formation. Very simple way. So that it is called sol gel process. And the gel formed once you dry it up. And due to this, what happens? There are two things will happen if it is a evaporative drying and supercritical drying. So there are two. That means it is all totally depend on the temperature of operation. If the temperature operation is very high, then we will get a supercritical drying. It is called. And what product will get is the sol gel formation. That product what we get is aerogel. And under the gel, after drying, we get the evaporative drying, that will be called as xerogel. Xerogel and aerogel, whatever it is, finally it will be a nanoparticle compound. It will be a nanoparticle compound. Okay, and that will be ready. That will be ready to go for the synthesis. The steps involved in this solution gel process is hydrolysis, the condensation, and the drying. You can see that the hydrolysis, this particular portion is hydrolysis, and this particular thing is the condensation. The condensation. After the condensation, it will get a gel. Okay, before condensation, you cannot get a gel. And gel, once you go for the drying, then if it is a super drying, it will be called supercritical drying. And if it is nominal drying, it will be called as evaporative drying. So whether it is evaporative drying or a supercritical drying, finally what we'll get is a compound which consists of the nanoparticles. And that can be taken for the next step. And what are the advantages of sol gel technique? There is a possibility that it will provide a thin bond coating, and it will be having very good, excellent addition property. That means it can metallic substrate. It can be used in between the metallic substrate as a top coating. As a top coating to prevent the formation of rust on the surface. And it will be very economical as compared to the other methods. The product will be very good quality. What we get from this sol gel formation process, and it will be very simple one, economic and effective method. Okay, and another important thing is that all the mechanical components and so very complicated shapes will be there. So this sol gel state, what happens? No, whatever the state or whatever the shape of metal is, it will be presuming the same shape. Okay, so geometry, the complexity geometry is not a matter here in the sol gel coating. Okay, and the coating, the formation of coating can be decided based on how much you required, whether you require 5 microns, 6 microns. It is not possible to go for the together. It is not possible. In terms of microns, you can make a coating over. Okay, it can act like a very protective layer to keep the material away from the corrosion. Okay, and another one, because of this organometallic precursors we get, okay, and it can be dissolved into many solvents. It can be dissolved into many solvents. And why the solvent is required? Because the sol gel, what we get, the paste that has to be uniform distributed over the surface of the metal. Just like we take a paint, we want to make a painting over the wall, directly we cannot do it. We have to add it with the thinner so that this component can be easily flow. To increase the flowability, we are going to use the thinner in the similar way here to make it into hydrolyzed solvent. So we are going to use some kind of specific solvents we'll be using, so that it can be deposited in any kind of complex shape, and it can be dried up at very faster rate. Okay, and another one thing, please remember, it is having the low sintering temperature up to 600 degrees centigrade. What is the meaning of sintering? Anyone can able to tell me? Sintering is one. What is the sintering? Sintering is a method of drying. It is a heating. We are going to convert this gel solution into the harder coat. That is the sintering process. Okay, these are some of the very important advantages of going for the solution gel technique. That is sol gel technique. Okay, anyone have any kind of discussions, you can have, no problem. If you go for the furnace method, that is gas phase synthesis of nanoparticles, and in this furnace method, this particular material will be heated up in the crucible, not in the normal utensils. The crucible will be a ceramic one, and it can be heated up to 2000 degrees centigrade. Even more than that, the crucible will not change the shape. Metal can be melted and it can be made into liquid shape. And the metal to be evaporated will be kept into this crucible, a ceramic crucible, and around which there will be heat insulations will be made. That means it will not allow the heat to go away from the system. And at elevated temperature, the metals will evaporate. The metal will evaporate, and we'll get the clusters of the nanoparticles. The nanoparticles already they are existing in this metal, and we are going to collect the cluster. That means a collective nanoparticles are collected nanoparticles. We can say it's a clusters of nanoparticles, but it is not distributed to my requirement to call it as a nanomaterial or nanosynthesis. Because if you have taken any part of the this one, the nanoparticles should disperse uniformly. That is what we require, so that we can get the uniform mechanical, physical, and chemical properties we can get on the entire surface of the coating what we do. And these nanoparticles will be collected and they'll be hold on a cold plate, and they can be taken for the next synthesis purpose. That is called the furnace method. And advantages of gas phase synthesis. The gas phase synthesis which have the opportunity to control the size shape of the nanoparticles. But here, in case of the ball mill process, in mechanical process, it was not possible. It is possible, but all the metals cannot be converted into. Around 30 to 40% of the things will be as it is, and it has to be recirculated once again. And we can get pure materials. In other method, just like in the ball mill, what happens? The ball mill material itself will be producing some kind of its nanoparticles. That is not required. Essentially, it is not required. So even though it is not required, it is not avoidable, and it will be mixed with these particles and behaves in a different way. You know that the nanoparticle, single nanoparticle will be behaving that one way, and when you take the cluster of nanoparticles, its behavior it will be different totally. And please imagine how if you are going to add up the ferrous materials or the material, the grinded material of the equipment itself, it will be behaving in a very, very different way. Okay, so that here it will be a pure material we can get, and the chemical reaction, the reactions can be controlled by means of a mechanism. Okay, the reaction mechanisms can be controlled. So It will be yielding you uniform shape and size nanoparticles. Okay, uniform shape and size nanoparticles. And another one, gas condensation process. Please do not get confused as in how we go to the next steps. What happens? Many other processes will come across. Then finally we'll put into complications. The title will be belongs to one and the content will be something else different. It should not happen. Gas condensation method. That means the gas will be formed and by condensing the gas, we are going to get the nanoparticles. Okay, and in this the gas condensation process, a plasma is made to flow over this metal. So due to what happened, the metal will melts, and after melting it will be evaporated, and the reactive gas will be there. The reactive gas, what happens, it will be separating the nanoparticles themselves. And once immediately after this reactive gas, there will be a cooling system. The molecular cluster will get out of which after the cooling. After condensation, we'll get this. And these nanoparticles, what we get, will be ready for next process, that is a synthesis. This is called the gas condensation process. The next one.